So today's lesson 2-4, area models for fraction multiplication. So last lesson we worked on using number lines and fraction strips to show fractions of fractions. This time we're doing what's called an area model. This example over here is called an area model. So if we look at the problem, it says number 1, the town of Andersonville turned an empty lot into a community garden with rectangular garden beds. Alicia was excited to be the first to work on the garden. She planted 2/3 of 1/2 of the garden bed on her first day. So describe how the diagram on the right represents the problem. How does that show me 2/3 of 1/2? Emmett?
The box is the garden bed.
Mm-hmm.
And if you were to cut it in half, then cut 1/2 of 3 and 3/3, and then you planted 2/3.
Good. So which way is it divided into halves? Is it horizontally or vertically? Jagger?
Vertically.
Vertically. So if we pretend that we're only looking at, so here's our whole garden. As Emma said, this whole box is the whole garden. Here's our vertical line that's cutting it in half. So that's where we're showing half of the garden. Then we're taking that half and we're cutting it horizontally into thirds. So then we're shading in just the 2/3. So you see how on these 2/3 here, the crossing is double. So on the thirds, it's going this way. On the halves, it's going this way. And where they overlap is the part that she actually planted. So we would say the whole rectangle is the garden, and it's cut in half vertically. Who's my light switcher? Number two. Devin, will you hit the lights? Aren't you just light switcher? Did I not change you? Oh.
You didn't get to do it much, though. Emma did it a lot.
She did it a few times, yeah. There. Is that better? Can you see it better, guys? So the whole rectangle is the garden, and it's cut in half vertically. Then it's cut in thirds horizontally. Zoom in up here. And where they overlap is the part she planted. The area models, I don't know if you guys covered that.
Yeah, I did.
You did that last year? Okay, good. So it shouldn't be brand new. And then it wants us to write an actual number sentence for the problem. So if she planted 2/3 of 1/2, What am I doing there? What operation is that telling me to do? Evelyn?
2/3 times 1/2
Good. What clue word did I say that made you think of multiplication?
of.
Of. Again, up here on that of. 2/3 of 1/2. Put your little multiplication symbol under the of to remind you that that tells you you are multiplying this. So that would be 2/3 times 1/2. And if I work that out, what does that give me? How do I work out 2/3 times 1/2? Bailey, what do I do?
You multiply the numbers toward the same denominator, and you divide the top and multiply the same thing.
Not on multiplication. On multiplication, we just simply multiply the numerators, multiply the denominators. So if I multiply my numerators, I would end up with 2 times 1, which gives me what? 2. Fraction bar. Denominators, 3 times 2 gives me 6. Now, if we look back up at our drawing here, did I end up shading in 2 out of 6?
Yes.
Yes, I did. When I divided it in half vertically, I made 2 pieces. And when I divided those 2 pieces by thirds, I made 6 pieces. Then the shaded in, the double hatching here, is where she planted, so that gave me 2 out of all 6. Does that make sense? Okay. All right, let's move on down to number 2. So it says for problems 2 through 3, move this back a little. We're going to do our area models and then write a number sentence to represent the problems. So it says number 2, if Alicia planted 3/4 of 3/5 of the garden bed, what fraction of the bed did she plant? So what do I need to do? How do I make a number model, or not number model, area model to represent a garden that she planted 3/4 of 3/5 in? What should I do, Hayden?
You're gonna make your chart, so you're gonna draw your box and then you're gonna split that into bits.
Okay, so we're going to make my rectangle to represent the garden. And then we're going to cut it into, what'd you say, Hayden?
Bits like
Fifths, yep. And does it matter which way I cut them? Do I have to do fifths this way and fourths this way? No, it does not. Remember, what's that property that tells us it doesn't matter which way you do a multiplication problem? Izzy? Commutative tells us we can flip it. So it doesn't matter as long as we do fifths one way and fourths the other. So let's say we cut this into fifths. So we're going to have to try to kind of eyeball this since it's fifths. Doesn't have to be perfect, but just as close to even as you can get. So there are my fifths. And how many fifths does it say that she did? Elena? 3. So on my 3 out of 5, I'm going to kind of do what they did up at the top and go one way with my slash marks to kind of shade it in. So there's my 3 out of 5. Yeah, go ahead. And then, so I got my fifths shown. Now how do I show my fourths? If I put my fifths vertically, that means I need to put my fourths, Stavia, horizontally. So fourths are easier, right? I can cut it in half, and then in half, and in half. So now this is the part where you have to pretend like the other stuff you just did is not there anymore. So now you're just imagining only using the fourths. And how many of those fourths did it say that she used? Evelyn? 3/4. So now we're going to do these 3/4. So we do all 3 out of the 4. So now you do your shading, kind of do it the opposite way. So now you should have 2 that are empty that haven't been shaded at all. You should have 3 at the top shaded one way and 6 at the side shaded the other way. And then you should have this area here that it's both crisscrossing. And what I want you to do after you've done all your shading, I want you to kind of outline the area where they overlap. So if we look at the area that we overlap, how many pieces are in that highlighted box that we shaded both ways? John? 9. We have 3 across and 3 down, so 3 times 3 is 9. Out of how many boxes total? Izzy? 20. So what is my fraction of 3/4 of 3/5? What do I write for my fraction there then? Devin? How many pieces did we say is in the highlighted box here? 9, so that's my numerator. Out of how many total? How many in the whole thing? If we have 5 across the top and 4 down the side, how many do we have? 20. Good. So my fraction is 9/20. Now, who can tell me the number sentence to show what we just did? John? Very good. That of tells us that multiplication through 3/4 times 3/5. Now, if I do my normal multiplication of fractions, multiply those numerators. 3 times 3 gives me 9. 4 times 5 gives me
20.
Did I get the same answer? Yes.
You're just breaking it down.
Right. We're just showing what it actually means to take 3/4 of 3/5 of something instead of just simply doing the multiplication, because if you just did this, would you really understand what you were doing? You would know that you were multiplying, but other than that, if I said, show me 3/4 of 3/5, yeah, you'd just kind of probably stare at me like, what are you talking about? So now this is being able to show, okay, this is what I'm doing. I'm taking 3/5 of a whole thing, and then I'm cutting the 3/5 into fourths. All right, so let's look at number 3. Anton planted kale and celery as companion plants. He bought packages with an equal number of seeds. He used 1/3 of a package of kale seeds. He needed 6 times as many celery seeds. How many packages of celery seeds did he buy? This one's a little trickier. He used 1/3 of a package of kale seeds, and he needs 6 times that amount of celery seeds. What should I be doing there, Hayden? Right? We know that it was 6, or it'd be 1/3, and we need 6 times that. It's telling us 6 times as many. So we would be multiplying 6 times 1/3, but how do I show that? Here's the tricky part. How do I actually draw? John?
First, draw a rectangle.
Okay.
Then you explain the verbs. Like,
Do I only need one rectangle though?
what do you need? 2?
No. Tavia?
Need 6.
I need 6 because it's 6 times 1/3. So we need to draw 6. I'm going to do smaller so we can fit all 6. Blank spots. So there's my 6 times. And what do I need each of those 6 to have? Izzy?
1/3.
1/3. So each of these 6 holes, I'm going to break into what? May, what am I going to break them into? Thirds. So each of these, going to try to be as even as possible. Each of these 6 holes cut into thirds. And what do I need to shade in each of those 6 holes? Bailey, what do I need to shade in each of those 6 holes? He used 1/3 of the package and he needs 6 times that amount. Right. So we need to shade 1/3 of each package. Now, if I put all of those shaded pieces together, what would I end up with as my ending amount? Evelyn?
You'd have 12/3.
12/3.
Then like 4 whole pieces.
Would we have 12/3? How many shaded pieces do we have? 6/3, right? And if I have 6/3, what else? What can we call that, Jagger? What would 6/3 be the same as? Say it louder for me. 6/3 would be the same as what? Bailey?
2/3.
Not 2/3. Tavia? Just 2 whole. Yes, because we have, if we imagine putting this third here and this third here, that would give us what? Elena, what would that give me then? If I moved this shaded piece over here and this shaded piece over here, I would end up with a hole. And then if I did the same thing down here, I would end up with another hole. So I would have 2 holes. So I would put, I'm going to put 6/3 equals 2. And then someone tell me the number sentence that I need to write there. Ivan, what's the number sentence? If he has 1/3 of a package of kale seeds and he needs 6 times.
Well, 1/3
Mm-hmm. Or 6 times 1/3, either way, right? Since that commutative property tells us we can flip it. So if I put 6 times 1/3 equals, how would I work that out, Tavia? What do I need to do?
You can, well, it would equal 6/3 or 2.
What do I need to do that 6 though first before I can multiply? Right, I need to put that whole 6 over 1 and then I can multiply. 6 times 1 gives me 6. 1 times 3 gives me 3. And I end up with my 6/3, which is again the same as what? 2 holes. And then number 4 wants us to explain how the area models for problems 2 and 3 are different. So here's our area model for 2, here's our area model for 3. They look very different, right? Why, how are they different? What's different about them? Ava?
First graph is just one big graph, and the second one is just little graphs.
And why is it like that? Why is the first one big rectangle and the second one was 6 holes cut into fractions? Emma?
Because problem 3 has a whole number, which multiplication of number 2 doesn't have a whole number.
Right, what are we doing in number 2? What are we multiplying together there, Izzy?
Problem 2 dividing, multiplying 2 fractions, and then problem 3 is multiplying a whole.
Right. So in problem 2, we are doing fraction of a fraction. So that means we need to start with 1 whole, cut it into the first fraction, and then cut it into the second fraction so we can do the fraction of a fraction. On number 3, we have a fraction of a whole. So we have to show each of those wholes first and then figure out the shaded parts of it. So we could say that on problem 2, we are multiplying 2 fractions. So we used 1 rectangle. On problem 3, we multiplied a fraction and a whole number. So we had to represent the whole number first. Nope, not too hard. When we have a whole number, that's when it's just slightly trickier, right? Fraction times a fraction is pretty easy because you just draw 1 big rectangle, cut it into fractions one way, and then cut it into fractions the other way, and where it overlaps is your answer. The whole one is a little bit trickier. You have to make sure that you're making the right amount of whole pieces and cutting it into the right amount of fractions, and then adding up all those shaded pieces to get your answer. All right, that's where we'll stop for today. So we will finish lesson 2 for tomorrow.